Nintendo Switch. Let's see what's going on. Switch over to the microscope. Take a look at the port. The port has seen better days. We have at least a couple pins touching in there. I don't know if you can see that. Look to the far left. So we definitely don't want to plug this in and try to put power through it. Look at this other side. Yep, and we got a few more. Second and third pin on the left appear to be touching as well. So yeah, it could be very catastrophic if you tried to plug power into that. So we will disassemble. We will pull the board. We will prep to remove the port. We'll remove the port, then we'll do some testing. We may do some initial inspection just to see if there was anything catastrophic. If I tried to plug power to that, there could have been something catastrophic. So let's double check and make sure it's going to be worth pulling the port. So we'll be back. Okay, we're out of the housing and we're set up to remove the port. I already applied the flux, as you can see. I did a visual inspection of the board. I'm satisfied that there's nothing catastrophic looking. Real quick, I'm going to throw up my temperatures. These are the expected temperatures for this repair. I don't expect to use the Pico pencil, but if I do, that'll be the temperature I use it at. We're going to do what we always do. We're going to flood it with low melt. We're going to bring the sauce, and then we'll come back and do testing once the port is removed. Okay, so we can see how we did. No pull pads. Awesome. Good pull. Let's make sure we don't have any bridge connections. And we do. So we need to clear the bridge before we do any testing. Alright, all clear. Flip the board real quick. Alright. Keep it back to the microscope. And let's do some testing. We want to be on continuity. My main reason for being on continuity is so I don't have to look at the meter. It'll beep. Alright. So we're going to start, make sure you're in the picture. We're going to start on this capacitor, which is linked to Pi 3 USB, which is on the other side of the board. One side should be ground, one side should not be. Okay. And for the rest of these, we're going to be tracing the signal wires to the chip. Now, on certain capacitors, there will be two. And if there are two, one side will always be ground. But if it's one single line to the chip, it's typically just not something you want to be short to ground. Okay, so we do definitely have a short on M92T36. This is the signal line going to it from that cap, and it is shorted, so at least one. This one has two signal lines going to the chip, so one side's always going to be ground, which is that side. This one has two signal lines too. One, two. Actually, this one doesn't have signal line, two signal lines. This one has only one. This one has two. So one will always be ground. Okay, this is our CPU cap. Usually if this one is short, it's bad news, and we seem to be okay there. So definitely have an M92T36 issue. Let's move our way up the board. Check out our MOSFETs. Everything seems okay there. Check out our low filter. Our indestructible fuse is being indestructible. Let's check out our test pads. That one should be ground. The rest of these should not be. And we're shorted on that line. Now we know we have an M92 T36 problem, so that's likely connected to that issue. We're shorted on that line too. Well, we're shorted all over the place. None of those should be shorted to ground. Okay. And then this one should be. Okay. We're going to check around our BQ24193. First check our filter. Good. Okay, everything seems all right there. Let's flip it over, take a look at Pi 3 USB. We want continuity through these, but not side to side, straight through. It's sometimes a little bit difficult to get through the manufacturer residue, which is still on the board. Get this in screen for you. So don't get trolled by that. Okay, let's find ourselves the ground. Yeah, definitely don't have a ground if we're not getting a beep on one side. Okay, everything looks good on Pi. We definitely have an M92 T36 problem, so we will work on that next. Make sure those shorts get relieved. So what we'll do is we'll pull the chip, we'll remeasure, and we'll remeasure our test pads as well. I've not seen it with that many test pads short, so we could have additional issues. We'll find out. Or not. Okay, we're removed. We have a couple of lines shorted here, so we do need to clear that. And maybe others. Alright, let's test our areas for short again. Okay, our capacitor that was shorted is no longer shorted. So we check that. Yep. Okay, let's check our test pads again. And it has relieved all shorts on our test pads. If you remember right, these two were shorted, so the short is now gone. So let's put on a new chip and make a mental note that those are pretty much directly tied to M92. But we'll test again once we have a new chip on too. Let's not draw too many conclusions on that just yet. Okay, sorry, I didn't realize I didn't turn on the audio while I was testing. Everything's checking out, the shorts have not returned. Next up is we're going to clean up, we're going to put the new port on, and then we'll come back and do some more testing. I'm having a real problem getting my mic turned on today, apparently. Okay, I think we're ready to perform a quick test. Make sure we're getting somewhat normal-ish behavior. That is not normal-ish behavior. We're getting flat 0, 0, 0, 0, 0. All right, let me bring over my battery power squid. This will be on channel 2. Power that on. And I'm going to activate with my OEM. Wow, nothing. Interesting. Okay, let's perform another test. Let's grab my known good battery. And this time we'll test back on channel 1. Yeah, straight nothing. Did I get a dud in my 2? That is odd. So odd that I'm not quite buying it. Yeah, we're not even getting an activation. Yeah, nothing. Straight 0, nothing. Okay, interesting. Let's take a look at our M92T36 again. It should be making connection. It's a little off. Let's try a reflow and nudge. See if we just managed to not get it on there correct. Let's put it on that side. Alright, everything looks pretty well lined. See if we get any signs of life now. Okay, that's better. Still a little bit warm, so I don't want to do too much of a test here. A little rapid cool. Alright. Watching channel 1. Okay, that seems a little bit more normal. Okay, that seems a bit more normal. We'll throw on the battery squid. Channel 2. We'll activate with our OEM. Okay, that looks a lot better than it did just a second ago. So we just managed to misplace the M92T36. These things do happen even to somebody who is as practiced as I am at it. So, okay, so next issue is to clean it up. And then we'll put it in the housing enough to do a test or some testing and go from there. Okay, we're ready to perform a test with the known good battery. So again, we'll be on channel 1 on the PSU. Okay, pull battery symbol. Resetting. Fast charging. And we're in like Flynn. Hi, Dave. Alright, let's check our other side. Make sure we're fast charging on both sides. Seems to be being flaky. Try again. Okay, why are you doing that? There we go. Just being flaky. It's not charging on both sides, as you can see. 1.39. Okay. We're going to power it down. We're going to reassemble entirely. We're going to let it charge on its own battery for a little bit. Make sure we have no problems with that. And then we'll come back and do some more thorough testing and go from there. Okay, as you can see, we're back up and running. It's on its own battery now. We're up to about 16%. Let's run some tests. Make sure we're picking up our internet networks. And we are. Awesome. I'm going to grab my Joy-Cons. Oh, actually, they had Joy-Cons. I don't know why I'm grabbing mine. Grab theirs. Make sure we are charging and picking up. Okay, we're picking up and charging the Joy-Cons now. Very good. Let's try our game card reader. So we'll try our own game. And it picked it up. Awesome. Delete that. Very good. All right, we're going to set up for dock test, and then we'll go from there. Okay, as you can see in the top left, we have dock sync. Switch over to capture. So we're charging on both sides. We have dock sync. We're picking up our networks. We're reading games. It appears that we have solved our problem, and everything is good to go. Okay, in summary, we had a Nintendo Switch with a broken port. It was pretty a little bit mangled inside. We removed the port and proceeded with our testing, and we came up with shorts on the N92T36 on one of the caps near it, and we also came up with shorts on 2 test points that should not have been shorted to ground. We proceeded to remove the N92T36 and test again. All shorts were relieved. We put a new one back on. No shorts reoccurred. Unfortunately, we went to test and we were getting 0.00 amps. I looked at the M92 T36 a little closer and it was a bit misaligned, so we reflowed it back into place and tested again. Everything checked out. So even somebody who solves them all the time can screw up. It happened, like I said in a previous video, it happens to us all. So don't sweat it when it happens to you, because it's going to. Anyway, we reassembled. We performed all of our tests, our dock tests, network tests, Joy-Cons are charging fine, so everything's good to go. That's really it for this repair. If you have any questions about the equipment I use in this video, take a look in the description below. If you like this video, do me a favor and hit the like button on your way out. And if you want to see more videos like this, hit the subscribe button and the notification bell. You'll know when I post videos, which is about twice a week. If you have any questions, please post them in the comments below. I'll do my best to answer them, and if I can't, I'll direct you somewhere that I think can answer them. That's really all I had to ask of you. I really appreciate you watching. I really appreciate your channel support, and we'll see you next time.